I'm Didier Plaindoux. Right now, currently I'm the manager of LIGOLang, and we are going to present a joint work with.
Hello, my name is Hillard. I'm working at Smartchain, and we will present you all the development we did for scaffolding a new project very easily. So
why did you do this?
Why are we doing this? The goal is to help developers community to be able to kickstart a smart contract, a project without recoding everything. So being able to reuse code, basic referential code, a bit like in Open Zeppelin, where you can grab existing smart contract and then customize them. So that's the main goal.
Yeah, so during this work, what we do is try to improve our experience with LIGO, but also try to find and to spread what we call the good practices in order to spread and to share with the community. That's right, I guess, right?
Yeah, good practices, but also try to reuse the code and provide libraries, because we don't want to code every time the same thing. And all these libraries will provide maturity to the ecosystem. And also, as you know, there is a lot of protocol updates every 3 months, 4 months, and there is always new features, and the LIGO compiler always changes. So we also build up a CI/CD on top of these contracts and libraries that we do to ensure there is no regression, and it's trying to keep the code functional.
Yeah, and this one is good support also for two main syntaxes. As you know, we have 4 syntaxes right now, but 2 main syntaxes, which are JS-LIGO, which is the one we would like to push in order to be adopted by the community, and the other one, which is Camel-LIGO. So therefore, we have the imperative one and the functional one. So we both libraries, and it helps us in order to increase and to improve also the language, which is important. We have the kind of feedback, and this loop is really important also for us, and for different purposes. In fact, we have to see how people are going to work and to develop their contracts. Working with Smartchain, we have a short loop, so it helps us to have some new features and help to the experiment with LIGO. Amy.
Yes. So we provide all this material for you, for the community, and for all the people who likes LIGO, and we choose LIGO because we think it's a very good choice for language programming.
Yes, so what do we do? First, we propose a set of contracts, and the first one are related to TezDev. I don't know how to pronounce it in English, so I did TezDev, which is the French one, I guess. So the first one is to take the TezDev standards and implement it in order to bring, good practices with the contract, which reflects the standards which bring by Tezos. The second one is to take canonical smart contracts and try to implement this. So, for example, we have an auction and versioning with Lambda, but we have much more contracts which are related to this canonical smart contract. And you know that this field is still we're still working and try to find new canonical. So therefore, once we find a new one, we're going to bring it to the community. We're also going to bring some smart contracts. We are going to use last features defining in protocols. Like, for example, we know that we have the ticket, the chest, roll-up, and so on. So the target is also to illustrate and try to find new kind of contracts which are able to use this capability. So we know the chest and so on is okay, but roll-up, it's not so clear for a moment. But also, we have one side we have contract, but we would like also to push some libraries in order to have reusable units. And in December or January, I guess January, we announced that LIGO has a package management which is linked and based on AZ. So since we have this feature, we are going also to push new libraries which are which should be used by the community. So during this work, we also work on libraries, much more standard libraries, which can be used directly in the community. So for example, we have the float representation.
Yeah, we'll go into details of all these points in the future slides.
And of course, these libraries offer something which does not exist in Tezos. So you have no float representation. So we have to, have kind of a denotation, but at the LIGO side, at the LIGO level, right? Everything which is linked to the trigonometric.
Yeah, also.
And finally, try to improve generic list, adding new features with something which is kind of a la big array, which is a set of functions which are able to provide some features and so on based on a generic list. There are no monadic libraries, but maybe still in the future.
So let's talk about the implementation of TezDev. So you probably know about FA 1.2 and FA 2. So the goal was to try to find a way to keep the standard, but you always add new features to the standard. Like the standard just only define the update operators, the transfer, the balance, but for NFTs, you need mint and burn entry points, and sometimes even more if you have specific features to implement. So we end up with an implementation of FA2 following the TezDev 12 standard, but in where you can extend the storage easily. So if you need, for example, new elements in your storage of your FA2, you will be able to just define an extension of the storage. So we are using polymorphic types to be able to implement this kind of features. So we can, for example, here have a storage, and we can add inside the storage new fields. Here I made a field admin because you always need an administrator who will mint NFTs. Or, for example, if you want to have a new feature, you want to count every time a token has been transferred between persons. Then you can add a new field, and then you can add new entry points that will be able to deal with this functionality. So if I want to count every time a token is being used, I will override the transfer entry point, the transfer function of the FA2 standard to be able to customize and to count the number of transfer has been done. Or you can also add new entry points like the mint and burn entry points. So we end up with an implementation that is very easy. You have the core standard, and you implement I would say an extension of the standard. And this kind of extension also allows you to add new on-chain views. So it's a way that you reuse the FA2 standard, implementation standard, and then you can just write only the new override entry points, or the new entry points, or the extension of the storage. So.
And just for a comparison with the presentation which has been done yesterday about SmartPy, SmartPy already do some demonstration about FE2 with extension with Mint and so on. So in this version, we have a kind of extendable structures based on parametric types, which has been introduced in November and December in LIGO. So it's quite new also, quite young. Not new, but young. And here we are formalized, we're able to formalize extension and so on based on type. So we have really a formal approach, which is quite different in SmartPy. So here we have a point where we can compare both languages based on this implementation. And then we can see that the types play a great role here, describing and giving more information and so on, and semantics. And this also, of course, this TezDev standard it's offered, and you can download it and can use it, and of course, you can extend it quite easily.
So one of the other good practices that we want to introduce is the LIGO test framework. So we used to do all the testing with a Python library called Tezos, most of the developers. And but so if you're implementing your smart contract in LIGO, and then you're using another language, Python, to test it. So now there is a new test framework with LIGO, which allows you to launch a sandbox and to deploy and interact with the contract. So this is quite useful, and this is a replacement improvement.
And you have also something which is provided by test framework, which is not done by the other. You have some mutation testing. So you can do some unit testing, end-to-end testing, but you have also mutation testing. So we can improve the code which is not covered and so on, just modifying behind the scene the code to see if everything is going to be tested correctly. So if you do mutation testing, if your tests are okay, it means you have a problem because the test should be broken, okay? And just as an announcement, later we are going also to provide PBT, probability-based testing. So hopefully we are going to extend all the contracts here we are providing with PBT approach. So mainly we are able to also provide for the future, based on this this catalog, also the capability and the best practices also to have generative data and PBT approach. This is really important for us in order to improve to provide secure contracts and libraries. Based on this, we have also more specificity capabilities of the language that have been used.
Yes, the module. So the module is one of the enhancements of the language. We used to use the include directive to take a part of the code and include it inside, but it's just text replacement. Now we have a new directive called module, which allows you to to interpret another file, another file, and what you integrate into your source file is not just text, but is really something that has been interpreted. So it allows us to first organize your code a bit differently, but better. So you can make different files that have a whole reason by themselves, and also it allows you to mix the language, the different flavor of LIGO. So you can write a file in JS LIGO, and then another one in Camel LIGO, and another one in Pascal LIGO, and they all will be able to interact, to work together. So that's the way that if you want to reuse some code that has been done in Pascal LIGO, you don't have to translate everything into Camel LIGO if you want to implement Camel LIGO. So that's a huge ease.
Yeah, so the model lets you organize the code, and so you have to bring the types and so on, and the data types and the features in one compilation. I don't have to talk about compilation unit, but this is in fact the right word. So in JS LIGO we call this namespace, just to be sure that we are using the same word as in community coming from JavaScript, and for Camel LIGO it's module. So this is why we're talking about modules in general. So it lets us to organize the code per blocks, and therefore you're able to reuse it directly. So you can organize it. And of course, in order to be coherent, like OCaml, a file, it could be a module also. So once you import it, it's managed as a module. And following this, also it helps us in order to organize the code, but not only on modules, but on file organization. So based on these different smart contracts, as we explained, we try to find a right way to organize the code. For example, when you come from in Java and so on, you have a different aspect and different approach and canonical approach in order to organize your project. So this is what we try to tend also to try to reach as a goal. So it's not so easy. But we know that we have a main function, we identify main files and so on, and parameters also. It's kind of good practices also when we try to organize and to organize the source code. Okay, so I know that some people already do some blog posts on something like this and so on.
And finally, but not the least, library usage. I mean, we are going to put all this code into libraries, and we are having a package management, so we can load libraries and reuse the code. So.
So as a consequence, right now, what we are going to do is just to take some distance with the work which has been done in order to provide some kind of documentation, in order to share experiments during these developments. And this document is in preparation, so we're going to bring some approach and to share what we do in order to be able to let people to understand how to do maybe how to code and to organize our code and to have to follow what we call the best practice.
If we can standardize how we implement, it will be easier for every developers to have a common view of how the code should be. So as examples, we are implementing basic smart contracts, multi-signature, lambda pattern. I mean, how to do versioning and to change the behavior of a smart contract that has already been deployed. So this is not supposed to be done, but it can be done if someone is admin of the contract, and often the clients wants to change. They have a specific idea of when they start the project, but 3 months later they want new features, but they don't want to lose all the data that has been stored in the storage of the first contract. So how do we reuse this kind of data without we want to deploy version 2 of the contract without losing the data.
So this is a curious pattern because it's not secure at all.
It's even called an anti-pattern, exactly, but you can do a lot of things. There's also contract for token implementation. So we talked about the FA2 extended view, extended version. We also showed implementation of the NFT collection, DAO, randomness, how you produce a random number on-chain without bias.
On-chain.
Permits, the TezDev 17, to make a gas fee spent by someone else. You have to delegate the gas fee payment. And other contracts like an auction marketplace or other betting and predictive market smart contracts.
So, as mentioned before, one important part in this library is also to illustrate the new features we can bring by the protocols, the new protocols and so on. And for example, when we talk about new features, which are the data type like ticket, chest and rollup, right?
Yeah.
So for this purpose,
we make examples and we show how to use this. So one example was, let's take the chest. It's a new keyword on the language, but how you use it and what is it for us? So, for example, chest the goal is to obfuscate information. If we are playing a Shifumi together, and we implement a Shifumi, we won't never be able to play at the same time. It's not possible. So someone will have to say an order, like I pick a stone, and the other one will be able to check on the storage of the contract what's the choice of the user. So if he can see that I've chosen stone, then in the end he will always win. So the way it works is the chess is like a commit and reveal pattern. You have to say that you choose your order, but you hash it, or you lock it in a chest. You send the chest saying that you have chosen an action, and then when everybody has given a chest, we can reveal inside the chest what was the action, and then we can process the action. So paper against stone, the paper wins, and stuff like that. So we provide implementation example of these kind of new features that are being introduced in the new protocols.
Yeah, but this example, we don't bring a game engine, a generic one, because it's tough. We don't have enough time to do this. But this contract is much more to explain, highlight how to use a chest. So you can take it, and you can analyze it, and so on, and you can modify it as you want. Right? Yeah, but it's most important, yes. We have some libraries also. which has been done. The first, which is what we talked about it just before, which is the extension of generic lists with a bigger like.
You know that lists and generic lists already exist natively in Tezos, but they have just few operations on it. You can't split. You can't say I want the 3 first elements of a list and split it in 2. Oh, you can't fusion easily. So we implement those kind of types. Let's say polymorphic types with extra features. So that's one example of extending all the functionality that is provided on lists.
And one disclaimer, big is not like big map. You don't have the same features because a big map you have a lazy read operation, right? Here it's bigger range because we would like to manage big list. That's all, nothing else. Okay, it's not related to the capabilities to have a storage which is read seamlessly and the laziness. This is not a scale.
Other features that we introduce, conversions. So maybe you've seen that in LIGO it's not possible to convert a byte to a number. So we provide those kind of features. These kind of features are not natively implemented in LIGO, but we can implement a layer over LIGO as a library, LIGO libraries, that will provide those kind of functions that can be really helpful for developers. So bytes to NAT conversions, or knowing if an address is an implicit address or a contract address. So is it a TZ1 or a KT1 address? So you can, there is easy way to check this, but you have to go inside the internal representation of the address to see a certain byte. So we provide those kind of features, which helps. Because sometimes you need to have a different behavior if the caller, the sender, is a contract or is a person. You want to have a different, maybe a fee management is different if there is a contract that is calling you or if it's an account.
So yes, just a remark about the conversion. It helps us and show that the libraries and the language we have, does not bring enough features, because if you go through the function we do byte to NAT, you should be surprised by the number of line of code. You have around 264 if. Yeah? So it shows that we have some weakness also, but mainly we can do it, but at the university, if I do it, I have a 0. Okay, but this is a story. We have no choice.
And finally, also a math library. So, as you know, there is no floating point on LIGO, but you may need to use floating point because your client is really asking for something for operations that produce some number with decimals. So, we made this kind of representation. So there is a type. We can introduce a type float, which is represented as a scientific notation, m times 10 power b, and we handle all the numbers with this kind of representation. The goal is to be able to use floats. And as an example of this kind of usage of this float, we did trigonometric functions. So also sometimes you need sinus and cosinus functions. So we showed with this kind of library that you can implement cosinus and sinus functions based on a float representation, and all this is not natively supported by LIGO, but we can make a library that helps. So just for the cosinus and sinus, for example, we use the Chebyshev polynomials approximations that helps to make an approximation of the circle and the a quarter of a circle, and then we compute the Chebyshev coefficient, and now we have an implementation that is very quick and easy for computing sinus, and with the float representation, so you can also start to have square root of 3, square root of 2, and so you can verify your sinus and use numbers like pi. That can be useful not only for sinus and sinus, but also for, I don't know, physics and thermodynamic equation. There is sometimes a pi that is being introduced, so you need those kind of library to be able to compute scientific numbers.
So hopefully, since it's a library, you don't have to learn Chebyshev theory, right? It's amazing, but you don't have to. If you want, you do. So, how to use it? Because here we are talking about contracts, libraries, and so on. So the first one, which is quite new, which is not the command line interface, not the CLI. We have the package management, as mentioned before, thanks to Easy. So we have the capability to publish. So just one disclaimer, right now, once we want to publish, you have to use npm line command. So this is going to be changed in order to hide the registry. So in the future, we are going to provide different registries, and the CLI hides the registry you are going to use, right? So you have the possibility to publish, of course, but also to reuse. So the library which brings you some sinus, cosinus, and so on, it offers you directly can be used D1, thanks to the package management. But also we have a brand new one which has been announced 2 days before, as mentioned at the introduction. We have the CLI which has been extended by the init command. So if you are aware of, for example, Angular CLI and so on, you have this kind of init also. So here we have this new one, and it brings and offers you the scaffolding. So you have different capabilities. The first is to have the listing, to list the templates which are available right now. And we have also the capability to have this instantiation. And finally, each contract which has been written are going to be used. This is not yet finished. It's a work. It's an ongoing work, to be honest. So a bunch of front ends are going to be deployed and to developed and deployed in order to exhibit and show how to use the contracts and so on and so on. Okay, so once you pick up these examples, thanks to the scaffolding, you have the web, everything which is related to the deployment. So maybe this work could be linked with Stack Area soon or later. I don't know. We have to discuss with ECAD of course, also. We already start discussion about this, but also website in order to highlight and show you how to do have a full and complete solution based on a given contract. And that's all. So.
Thank you. So, do you have any questions or need something that is missing and you want a new library or
also
new
objection about libraries? Yes, of course.
I do have a question, actually. Do you have any...
The mic.
Oh, thank you. I tend to be way too impatient. Thank you very much. Thank you very much for this. That's wonderful. The only question I have is that, and it's absolutely not sure, do you have any plan to have a SmartPy version of it? Or if not, because everything ends up being compiled in Michelson, is there any way to use these brilliant features from or with a SmartPy contract?
Since we are going for LIGO, the response is no. To be honest, now, in fact, in LIGO we are working hard in order to increase and try to ease the adoption of the LIGO language. So this is our target because we think that LIGO is a good language. So we would like right now. SmartPy is widely used, to be honest. It's widely used, but we have also to have much more offer. In order to have different languages. This is not a war between language, but it's a matter of choice. So people who would like to do SmartPy, they can do it. If they want to use LIGO, they can do it. Both can interact thanks to Michelson virtual machine. That's perfect. But you have different approaches. For example, SmartPy, you have an approach which is based on side effects. So once you want to modify and mutate your storage, you have to do it as we do, for example, in Python. So this has been illustrated during yesterday during the presentation. LIGO has an approach which is quite different, which is based mainly on functional approach. So we can argue that a contract which is written in LIGO is pure. Okay, even if you have some imperative style in GSLIGO, the capability to mutate a variable and so on is in a given scope. It's not a global scope, it's a local scope. So this local scope offers and still offers the purity and the fact that the function is still pure. So we have different approach. So here we offer some. We provide the contract for LIGO in order to increase and to also to help us to understand how the community is going to use the language. This is the first step, and also these contracts are also used in order to be sure that we don't have any regression. We have unit tests, of course. We have integration tests. We also have tests based on different and executed and used contracts. So it is also important. So the relationship with SmartPy is there's not, but I think the offer should be large. So all this work has been done also in order to increase the LIGO and so on. So no for SmartPy, I'm sorry.
Thank you very much.
Okay.
Though you can still take the code and translate it into SmartPy.
When I will be a grown-up.
Okay.
Thank you guys for the presentation, and it's nice to see that the language evolves and and improves. Could you please a little bit elaborate about testing? You want to you told that you're going to go would like to developers go away from PTES, but what's the difference? What's the difference between testing with just LIGO? From what I got, it's mutation testing, right? And because Takuriel, another project, they show us like how they can do testing with Jest, right?
Yeah.
Basically, client is invoking contracts.
Yeah,
what's the difference between LIGO?
There's some overlapping because Takuriel offers based on Jest some capability to test, but the test is how to say language agnostic. Because it's based on Michelson. Here, the test framework is dedicated to LIGO, and all the tests are written in LIGO itself. So you can write your tests. And LIGO is, once you download the compiler, you also have the test framework, which is embedded in compiler. So you have the capability to have a specific test, a unit test, end-to-end test, integration test, and so on, which is written for LIGO and done for LIGO. And it's based on Michelson interpreter. So this is yes, you have this kind of overlap. The main advantage here with the contracts is the CI/CD play the test also. So all the tests are done, and we have some feedback about the compilation and the regression tests once we do some modification on the compiler also. So this is really important for us in order to have a serious development for the compiler. Okay. So you have different approach. So as mentioned by Frank. At the beginning, they use Tezos, right?
Yeah.
Yeah. And they switch to the testing framework. This is not. We are not pushing on this because they decide to do it by themselves because they love it. I don't say it because I'm a manager of LIGO. They already mentioned that we really love the testing framework because in to be honest, in 4 lines of code, you do end-to-end tests with origination of the contract, execution of the parameter, and checking the storage, and that's all. And 4 lines of code is it's really small, in fact. So it's really expressive, efficient. And as mentioned, we are also bringing new features like PBT and so on. And if you remember during a presentation yesterday, the automatic generation of random values and so on still work. Here we are going to provide this soon. So we would like to have a complete solution based on testing framework also.
Thank you.
No problem.
Also, if I can add a comment, all this work and all this contract that we are implementing and that we are testing with the test framework is in a way a way to get the product, this test framework, more mature and so we are debugging it, debugging all this test framework for you, for the community to be able to have something that works fine. And so all this work is to make all the tools mature for you.
Yeah, we have a learning loop, which is important also between the Smartchain people and the LIGO team. We have really a short loop and a feedback which is really very fast in order to increase and so on. Because the protocol is updated really quickly. So your new features like tickets and so on take times to be integrated and to find the right way also to design the right libraries in testing and so on. This is a huge work, to be honest. It's a huge work. It takes a lot of time during the LIGO development. Yeah.
It's more a remark than a question. When something is missing in Michelson, don't hesitate to ask. It will be our pleasure to extend. I mean, for instance, deciding the nature of the address, something that we can do really easily in Michelson with a new instruction. So, just ask.
Okay. Perfect. We can ask for recursive type.
You might have noticed
we have one which is the list, but
we have opened an MR to add recursive closures.
Okay.
We are in a good direction.
That's fine. No, not him. No.
Thank you. I have one wish. Would you like to share LIGO behind OPAM instead of just giving Docker image? Because it's very nice to can install LIGO via OPAM.
So the response is first we have to hide the registry, and then after maybe if we can try to provide it for OPAM, right? Yes.
Okay. And the second question is more about curiosity, but why did you have based your package manager on EZ, which I think that use a very complicated lattice of dependencies to have something like Nix, and it seemed a little bit overkill for a smart contract language?
So the response is simple. The two main developers, EZ, are working in Marigold.
Okay. Thank you very much.
So if we want feature, we have them, and we have open source approaches, which is quite shortened.
Okay. It's a nepotism.
Yep, that's the reality. Behind you. Je prends beaucoup de place en fait. Oui? Non, je prends beaucoup de place.
So, thank you for the presentation. I have a question about the instruction fail with in LIGO. So when I check the type of this instruction in LIGO, in Michelson, it can take any types. But in LIGO, it takes only strings. So why this limitation? And if it's possible to add at least primitive types to it?
Sorry, I didn't understand well the question. You are talking
about the instruction. The question is about the fail with.
The fail with. The fail with instruction that doesn't take only string, but you also can provide NAT or Tez or other. But actually, that's the fail with instruction inside your smart contract. And sometimes it's not easy to debug or to make a full debug message. But if you use the LIGO test framework, you can put some console log and debug your program a bit more.
It's a limitation. I agree with the fail with, because once we try to, for example, once you do some tests with a testing framework and you would like to test fail with coming from your contract, you have to do some deserialization, and deserialization is still from the object to string, and hopefully it's a weakness. Okay. So if you have some suggestion like this, do not hesitate, as mentioned by the previous person, do not hesitate to ask and to complain, saying, okay, it's quite poor, please bring us much more powerful, for example, expressiveness thanks to the fail with operation. We're still open.
Okay, thank you.
Thank you. Oh, no, not
No, just a question when looking at your presentation. Did you take a look if global table of constant can be an optimization for the registry?
You mean the constant?
I mean, when I use a library, I include a library in my LIGO program. I assume right now it will every time copy-paste the same Michelson code. And when you deploy on Tezos, maybe, I don't know if it's possible, but maybe we could deploy a constant for some library and use that constant from the contract to save some space in the origination.
It's true. It's something that could be done. I would say that for the moment it's an ongoing process and ongoing work. So to be able, I would say, to elevate to the constant, maybe we have to see if this library or this feature is actually really used. It's perfectly well done, and the community has no problem using it. So I think we'll need a bit of time to see if those kind of features can be promoted as a constant.
It should be seen as a kind of optimization. Yeah.
But the goal is, for example, for sinus or cosinus, which is totally something like generic and common, maybe this can be integrated into the Tezos ecosystem as a constant. Right, it could be nice. Any other questions? Come on. Okay.
All right, with that, let's give Franck and Didier a big round of applause.
Thank you.